I've got a bit of a sore throat, and it's got nothing to do with going drinking with Nurhack. So I'm hoping that I'm going to make it through the next 45 minutes or so, being able to speak. Also, thank you to the folks that organised my emotional support penguin, because it is quite scary being up here. So 45 minutes sounds like a long time. Hopefully it won't feel like a long time to all of you, and if it does, I'm really sorry. But I'm going to go through it as quickly as I can, because there's a lot of stuff to cover. So a little bit about me very quickly, and this won't take long, because this is not the most interesting thing. So I'm head of technology at Air Studios. We're based in the southwest of England, near Bath, and we build digital experiences for organisations that are doing positive things for people and for the planet. So the likes of the BBC, Dogs Trust, who are one of the largest charities in the UK, and most recently, and excitingly for me, we are about to launch our first Umbraco website, because we'd never worked with Umbraco until I joined about a year ago, for Great Ormond Street Hospital, who own the rights to Peter Pan and Neverland, so that's really exciting. And previously I was at Great State, and some of my colleagues might be in this room from there as well. I like animals a lot, not just penguins. I like climbing trees, because I think everyone should climb trees. It's fun. What I don't like is sustainability talks that are filled with AI-generated images, because I think it's a bit hypocritical. I've got some in this. But there's two reasons why I think that's okay. The first is that I generated all the images on this laptop, and you'll be able to tell that, because they look a bit shit. And the second reason is that I use solar power. So I think that's okay. Am I a hypocrite? You meant to say no. Okay, great. Okay, good. No, thank you. Okay, so today we're going to cover not just sustainability, although that is a big part of the talk today. We're going to talk about sustainability concerns when it comes to AI, but also more general risks around using it, privacy concerns. I'm going to give some practical examples of how we use it where I work, and which I think selfishly is interesting, and some other sort of tips and approaches for this stuff. So the other thing to say is, just to keep you all interested, if you take nothing away from this presentation, you will take some interesting facts about different types of penguins. So every now and then I'm going to throw a penguin up on the screen, and you're all going to listen to me talk about it. So this is a king penguin. What a beautiful animal. Big. So is this too detailed, too scientific? There are 2.2 million breeding pairs of I promise this whole talk is not me just talking about penguins, but what a beautiful animal. There aren't that many of them left. Great feathers. Really nice. I would give them 13 out of 10. So there's a little fact for you. So I thought I'd start off, and what I've tried to do is not assume that everyone in this room is technical, and not everyone in this room knows the background to AI. So I'm going to spend a little bit of time just going over the recent history of it, because I think it's interesting, and this is my talk, and I can do whatever I want. So starting in 1950, which was a fair while ago, I've got a very historically accurate photo of Alan Turing, and he published a paper outlining what he called the imitation game. And this was a kind of early example of people starting to think about machines becoming capable of imitating humans, and very much in the way that we're seeing now with ChatGPT. And this was the start of a big hype bubble when it comes to AI. Then a fellow called John McCarthy came along and came up with the phrase artificial intelligence, which is a pretty cool thing to have, in the footnotes of your history. But in 1958, a man called Frank Rosenblatt invented something called the perceptron, which sounds like a transformer, but it's actually an early type of neural network. So there was a lot going on in the early 50s. But what we've seen with this technology is that everyone gets super excited about it, thinks it's going to change the world, everything's amazing. And then these two came along and published a paper highlighting some limitations of this perceptron technology, and then everyone got very sad and didn't do much with AI for a while. And this is a theme that we see with lots of technology. In 1986, a man called Geoffrey Hinton got everyone excited again. So the hype bubble started building when he put forward a concept called backpropagation. And I'll explain what that is in a bit, because it's important. In 1997, IBM's AI beat Garry Kasparov, the world chess champion at chess, and he was really sad about it. Beating humans at chess with machines is not a big deal now, but back then it was. And then in 2017, Google researchers published a paper called Attention is All You Need, which some of you might have come across. And this is when the transformer architecture that underpins large language models as we know them today, that's when that was proposed. And all of the amazing stuff you can do with this technology now is effectively built off the back of that, which is built off the back of all the other stuff that came before. So there was a talk yesterday, or it might have been in the awards, when someone said they were standing on the shoulders of giants with the work they've done. I think that's true for the entire history of computing, and it's certainly true for AI. In 2022, ChatGPT came along. And for me, the first time you can have a computer could understand what you were asking and give you a coherent, relevant answer still blows my mind. And it makes me slightly upset that more people aren't excited and amazed by this technology. And I'll come on to talk about that in a minute. Who knows what will happen in the next few years, but hopefully not that. So, everyone doing okay? Just have another quick penguin break, if that's okay. So this is an emperor penguin, biggest. They are the biggest of the penguins. Well, not those ones, but the tall ones. They can be up to 1.3 meters tall and weigh 40 kilograms. Look at those babies. And I give that a 12 out of 10. So, again, some of you might know this, some of you might not know this. I'm going to zip through it really quickly because I'm worried I'm going to run out of time. I have no idea how long I've got left. What are large language models? So we all use them. I'm assuming everyone in this room has used this sort of technology. But what are they and how do they work? So to me, there's two types of AI, and this whole section is going to be slightly oversimplified, so bear with me. What I call traditional AI, or machine learning, really good at things like prediction, identifying trends and anomalies in lots of data, classifying things, and this stuff's been around for ages. I mean, there's probably a bunch of people here who've used Azure's AI services before large language models came along. Very useful, very cool. Generative AI, what's that useful for? Stupid memes, so turning yourself into an action figure and doing your work for you. Now, I'm being slightly cheeky there, but this is part of the problem when it comes to sustainability, and I'll come on to talk about that in a second. So when people say AI now, what they're actually meaning a lot of the time is this column on the right. But AI goes back way, way, way further than that, as we saw earlier. So how do they work? Now, I'm not an expert on the internals of how these things work, so I'm going to do my very best to try and explain this in a way that makes sense. So if it's really painful, it won't take long. We'll see another penguin soon, and then I'll talk about some other stuff. So just hang in there. Everyone seems to be okay. Nobody's crying yet. So there are two phases in the life cycle of a large language model, as I see it. There's the training phase, which is creating it and teaching it how to behave, and then there's the inference phase, which I think is just a clever word for saying using it, because obviously scientists like to use clever words because it makes them sound clever. So the training phase is really interesting. This is where it all gets a little bit, let's go for it. You start off, if you want to train a large language model, you start off with a shitload of data. We'll just think about text for now. So that could be, you've scraped the last 5 years of Reddit comments. You could use that to train a large language model. There are open data sets on the internet like Common Crawl, which you could download and use if you wanted to do this yourself. But you take a bunch of text, you chop it up into bits. That's called tokenizing. And those tokens could be words. So you take all the text and chop it into individual words. It could be bits of words. There's different ways of doing it. I'm not going to go into it because I'll rapidly run out of intelligence. But the next bit, this is where it does get complicated, and this is key to how they work. Those tokens get transformed into something called embeddings. And I promise I'm not going to talk about this for long, but I've practiced it a lot, so I'm going to say it anyway. If you imagine a graph on a piece of paper with an x-axis and a y-axis, if you wanted to represent a point on that graph, you'd use coordinates, also known as a vector. So, for example, you go along 2 on the x-axis, 3 up on the y-axis, and you have a pair of coordinates that represents that point in space. Large language models use a similar concept to represent information, but instead of having an x and a y, 2 dimensions, they have hundreds or potentially thousands of dimensions. And each one of those is a data point that means something. It means something very weird and machine-y that wouldn't make any sense to us. But this is how they identify similarities between different tokens and what they mean. So you chop up your data, not literally, you turn it into embeddings, and then the large language model tries to predict, when given an input, a set of these embeddings, tokens, what comes next. So James went to the, now NeurHack might say the next thing would be pub, or Codegarden. So the large language model, when it starts off, it doesn't know a great deal. So it's given a bunch of inputs, it's asked to guess what the thing that comes next is. But the key part of the training process is it's then given the right answer, and it calculates the difference between the right answer from the data and what it thinks the right answer should be. And it uses something called a loss function to calculate that difference. And if you remember, about 10 minutes ago, I talked about something called backpropagation. It uses backpropagation to update all of its internal values, all of those embeddings, to better reflect what the right answer should be. Complicated, mind-blowing, crazy stuff. Do that billions and billions of times, spend hundreds of millions of pounds in some cases, and you end up with a fully trained model that is able to be useful. And there's a bit of tuning at the end sometimes to make it behave more like the people who are creating it would like it to. So that's training. Inference is not dissimilar. So this is where you'd say, hey, ChatGPT, can you write a presentation for Codegarden for me? And it does it. So you give it an input, it chops it up into tokens, it turns it into embeddings. But because it's been trained, it now understands how to represent those tokens as embeddings and understands the meaning. It's then able to predict what's likely to come next from the input, and then it turns it back into human language and gives you your result. Hopefully that wasn't too painful. So there's a lot going on here, and this stuff is expensive. Training in particular is a very expensive activity. The Chinese folks who created DeepSeek seemingly managed to do this for a lot less money than everyone else, but I don't know whether that's been verified yet. But generally speaking, this is expensive. So just take a little breather for a second. Let's move on to talking about the environmental impact of this stuff. And the key question really being, is ChatGPT killing the penguins? Is it actually killing the penguins? I don't think so, but it's hard to say. I changed this, it was a bit ruder than this, because they won't tell us how much carbon it's responsible for emitting, generally speaking. And this is a massive problem, and I'll explain why in a second. But because of that, there's lots of varying opinions that you'll find online about the impact of this stuff, and it makes it very, very confusing and difficult to form your own opinion. So by they, I'm talking about the likes of OpenAI, Google, Microsoft, etc. And it's very much not in the interests of these companies to talk about the carbon impact of this technology. If it was a good thing, they'd be talking about it. If it was having a beneficial effect on the planet, you can bet they'd be talking about it. The fact that they're not, you can probably infer something from that. What can we find out? So you've all seen Google now has changed, and it's no longer a search engine that gives you results. It's this bloody thing. And if you put into Google, how much energy does a ChatGPT query typically use? And I'm going to talk about energy instead of carbon emissions because I think it's simpler and easier to reason about. But ultimately, the carbon emissions is what we care about. Google says a single ChatGPT query typically uses around 2.9 watt-hours of electricity, 10 times more than a Google search. It says that very confidently, but actually I think it's wrong. That's an old statistic. There was a study done by an organization called Epoch AI, and it's a very good study, and there's a link to it in the deck. Excuse me, so you can download it afterwards if you'd like to and read it. They think that figure's been overestimated by a factor of 10 times. And that difference comes from more efficient models, more efficient hardware, and what they've said is an overly pessimistic estimate of token count, so how many tokens are being put into the input. But again, because these providers don't actually give us the data, it's really annoying. Nearly said a bad word. If you ask ChatGPT what it thinks, it's actually got a surprisingly helpful and nuanced answer compared to Google, which was terrible. So it's saying it depends. So the energy required for something like ChatGPT to respond to a prompt depends on the size of the model, where the infrastructure it's running on, how efficient the data center is. That can make a huge difference as well, because obviously there's a big movement towards renewable energy for data centers and so on. And it gives a rough estimate, which is roughly in line with the study from Epoch AI that I showed just now. Evil AI overlord Sam Altman, who you might have heard of, when he's not in his volcanic villainous super layer, posted a very self-indulgent blog post recently, which you can ignore most of. But one thing that was quite interesting is he actually talked about the energy utilization of this stuff. So this is from the horse's mouth, as it were, or the supervillain's mouth. And he said the average query for ChatGPT, and this is the guy that runs ChatGPT, uses about 0.34 watt-hours, about what an oven would use in a little over 1 second, or a blah, 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 blah. And he's saying that it also uses 0.85 gallons of water, 1/15 of a teaspoon. That's fine, isn't it? Doesn't sound like a lot, until you multiply it by the hundreds of millions of requests that people are making to this stuff every day. And what's an average query? What does that mean? Like, some people are using it to write university essays. Some people are using it to make stupid memes. Some people are using it to help them code. Some people are using it to help them summarize documents. I'd love to know what the criteria is, and it makes me really annoyed that when people make these statements, especially someone in a position of responsibility like him, because it's impossible to reason about a quote like that. It doesn't really mean anything. And especially an average could be, huge. I'll get off my soapbox. So it's really difficult to find out what's going on. I've talked about that Epoch AI paper there, but even within there, there's some stats that are contradictory, so depending on what you Google, you will find different things that might shape your opinion in a certain way, and we're definitely moving to a world of disinformation. If you look at Google's VO3 model, for example, I don't know if you folks have seen that. It's terrifying. It's incredibly realistic AI-generated video with realistic audio and speech. It's becoming increasingly difficult to find out what's actually true, which is a real concern. But a lot of these stats assume text prompts as well. So image generation is now a thing. Video generation is now a thing. That typically is more carbon intensive. A lot of the stats you'll find are based on estimates, and we've talked about this already, and they're based on specific models. The Epoch AI thing, I've got a link there. The second thing that I would suggest you all read is a really brilliant paper by the Green Web Foundation, written by my friend Hannah Smith, which is a very well-researched and, I think, fairly unbiased overview of the current state of knowledge when it comes to the carbon impact of this stuff. I would encourage everyone to read it. What else can we find out? We're nearly done this section. Hugging Face. Who's heard of Hugging Face? Hands. Yay, thanks. That's good. So Hugging Face did a study where they looked at different models, different large language models, their total carbon emissions. They measured this stuff, and they mapped it against the number of parameters. And parameters is broadly a kind of a view of the complexity and the cleverness of a large language model. So you can see models there ranging from a couple of million parameters all the way up to 10 billion. What they found with that research is that multi-purpose large language models, so ones that are able to do a whole bunch of different things, are a lot more energy intensive than task-specific models that have been trained to do one thing. And that remains across models with similar number of parameters. So in other words, if you're using a multi-purpose large language model to do everything, you are using more energy than you need to. Use the right tool for the job is something that we would say in the UK. And unsurprisingly, image generation is significantly more carbon intensive than text. Not a great surprise, but it's still good to actually confirm this stuff with a proper methodology. Apple released a paper about 3 weeks ago. Has anyone read that one? Gentleman there. So this was very controversial because their paper basically says that simpler models, so ones with less parameters, are better at low complexity tasks than reasoning models. And for those of you who haven't come across a reasoning model, it's ChatGPT has one. There are other ones out there as well. It's broadly described as thinking about stuff before answering. Is the simplest way of describing it. What Apple what they're saying in their paper is that actually those things are quite bad at doing simple tasks, and you shouldn't use them for it. Complex tasks are better suited to reasoning models, but they also said, and this is the controversial bit, that standard large language models and the clever thinking ones both just collapse when they're faced with something that's sufficiently complex. Paraphrasing that, what they're saying is that they think large language models are kind of a dead end. So some people think that large language models will lead to artificial general intelligence, so the Terminator 2 style thing, hopefully not that. But machines being smarter than humans, Apple is sort of saying, well, it doesn't look that way right now. It's very difficult to say. Writing this talk was a nightmare because things are changing every week, every 2 days. They released a paper, which was really annoying of them, so I had to read that. It's a very fast-moving field. But it's not just energy we have to think about here. So if we think back to Sam Altman's teaspoon, all of these things need water. Data centers use tons of water. Power generation facilities use lots and lots of water. Lithography, which is the process that's used to make chips, CPUs, GPUs, all that sort of stuff, uses lots of ultra-pure water to make that happen. Rare earth mining, used in all of the computers or most of the kind of technology that we use today, uses loads and loads of water to mine, and it's also typically mined in countries where they may have water scarcity issues or it's not done in a particularly safe way. This stuff is bad as well. So who should be responsible for making people aware of all the stuff that I've just talked about? Because most people, they pick up their phone and they type in a website address or they ask ChatGPT to do something and it just works and it's magic and that's great. They don't question how it works. They don't think about the hidden cost of this stuff. The fact that you're all sat here in this room shows that you do, because you wouldn't be sat here otherwise. Or maybe you're lost, I don't know. But you're here now and it'd be rude to leave, so you can't. I've run some panels recently, one in London at South by Southwest and one in Bath. And this was one of the questions that I asked the panelists, is whose job is it to educate people and make them aware that there is a carbon impact to using this stuff? Because a lot of the time, people will say, oh, digital's, 4% of global carbon emissions or something like that. Industrial shipping's worse, blah, blah, blah. I think that's a really terrible attitude. It's a hell of a lot harder to decarbonize heavy industry than it is to think before you use this technology or follow some of the sustainability advice that, for example, the Umbraco community sustainability team that we talk about. It's so easy. This is one of the easiest industries on the planet to make a difference. With a few lines of code, because of the scale, you can actually do stuff. But the panels, according to the panelists that I talked to, we can't rely on consumers to educate themselves, and I think they're right. Most people aren't going to question this stuff. It just works. It makes their life more convenient, and actually that's okay. Companies don't generally give a shit about anything other than shareholders. Sorry, but I think that's true. There are some exceptions, but broadly they exist to make their shareholders money. Coming back to what I said at the start about Microsoft and Google and so on, if there was a positive impact from a carbon point of view to this technology that they're building, they would be shouting about it because it will increase the shareholder value. So I don't think we can rely on most companies. Is legislation the answer? So should governments be regulating this stuff? I don't think that will work either, because there's an arms race going on with AI at a macro level and at a micro level. At the macro level, you've got a cluster of supervillains on the west coast of America who are building this stuff and are obviously right at the forefront of it. And then you've got the Chinese are doing some really interesting stuff as well. Europe is slowly waking up. And none of these countries want to be left behind with this stuff. They've got to try and keep up because it's a massive, massive advantage and potentially a bit of an existential threat if they don't. So at the macro level, no one wants to slow down. No one wants to regulate AI too much because it will stifle growth. And at the micro level, as individuals, all of us in this room, you don't want to be slower or less efficient than your colleagues either. And if everyone else is using it, it becomes this kind of effect where you've got to be using this stuff to keep up, which leads to this kind of ongoing cycle of just everyone using it and, sod the consequences. So it's really, really difficult. So I was chatting to my mate Dave the other day, and this is where this whole talk might go slightly, ignore the top one. This is where this all might go slightly wrong. And he said, and this is real, it's completely legit, why can't we just run a large language model locally and measure the power draw on the machine? Like, surely the laptop can tell us how much power it's using, and then we could extrapolate from there, make some assumptions, and that'd be good, wouldn't it? But that turns out that's quite hard. But I want to try it anyway, just to show you. So this is where it might all go horribly wrong. So I'm using a Mac. I'm conscious that a lot of people in here might be using Windows for historical Umbraco-y reasons. So here we go. I'm going to try and put something on the screen and hope to God that it works. So can you see that? So this is built into Macs, and this is where I thought I'd start. It's called Activity Monitor. It's much like Task Manager in Windows. How am I doing for time? I think I'm doing OK. Yeah, cool. And it gives you a really helpful energy impact score. That means nothing. What does that mean? 29? 29 what? Useless. Absolutely pointless. So I gave up on that because no one could seem to figure out what the hell any of it actually meant. I then installed a bunch of plugins up here that are supposed to tell you how much power your laptop's drawing. That didn't work very well either. So what I ended up doing, I don't know if you can see this, yeah, is I bought a little device off the internet. And I'm going to attempt to show you what it says using the magic of technology. So bear with me 1 second. No, that's not right. What's it called? Photo. There we go. Right. Hang on a sec. Just talk amongst yourselves. That's fine. Android. So, oh, God. There we go. Right. This is very much an experiment for me. So can you see that? There we go. Look at that. So currently, my laptop is drawing. That's backwards, isn't it? Good. I don't know how to fix that, and I will run out of time, so let's pretend it's not backwards. This was me trying to be clever. Actually, no one can understand what it says. So it's currently drawing about 20 watts of power. I'm going to turn that off, and we won't talk about that. So let's say, for example, we want to fire up this isn't a large language model. This is a stable diffusion-based image generation tool. And this is what I use to generate some of the images that you've seen in the talk. So we'll wait for that to work, and I'll read it out. So I'm now drawing about 20 watts still. Let me drag this over so you can see what I'm doing. There we go. So if we go into here, and this is really hard to do from this angle, and we're going to use this model here called Cyber Realistic. And what should we? Sorry? The what? Oh yeah, that's much easier. Thank you. I forgot there's a screen there. So let's give it a prompt. So some Danish people happily smiling. Yeah, that's much easier actually. Smiling and doing happy Danish things. Let's do that. This is going to be really interesting to see what this comes out with. And just as a spoiler, it's probably going to be terrifying because this model's not great. So if I hit generate, so we're at 14 watts right now. That's shot up immediately to 30 watts of power draw. Now it's 44, 45. So you can see, and this is not the most sophisticated as you're about to see. This is probably going to be absolutely horrific. It's not far off maxing out the charger. Oh, do you know what? That's only slightly creepy. That's not bad. Then when I was rehearsing yesterday, it came out with some really weird shit. So that's good. I'll save it, and if anyone would like a copy of it, then I'll send it round. I don't want to look at them anymore. That's quite scary. Right, everyone taking a picture. So that's good. So there's an immediate energy impact of this stuff. If we fire up Olama, which is a way of running large language models on a laptop, because this is the great thing. You don't have to use cloud services to do this stuff. You can run stuff locally. It's not as good as we've seen. So why don't we say, tell me about Odense in Denmark, and be super wordy about it. So 15 watts of draw currently. That's now shot up to 34, 54. So this is actually more energy intensive than generating the scary, creepy people in Odense town centre. So there's an immediate impact to this stuff. This isn't a particularly scientific thing that I'm showing you, but what I want to demonstrate is that there is a cost, even something as basic as that. And imagine if you scale that out by the numbers of people using Claude and ChatGPT and Azure AI and all the rest of it, and the fact that people are essentially, let's say, spending 2 hours getting the perfect AI-generated image of themselves in a little action figure box. There's a massive potential cost to this. The thing that upsets me is that I can't tell you exactly what it is, because that information isn't available. But you can be sure that there is a cost. Let's move that out of the way. I'm not going to read that out. Oh, hang on. There we go. So there's a definite cost to this stuff. This wall adapter was a great little purchase. So what can you do? So this is my take on things. And this is where I might rant a little bit, so I'm sorry. And I'm not ranting at you. I'm ranting at humans. We're the problem, not large language models. Human beings are really bad at thinking about other human beings, the planet, and long-term consequences generally. If we weren't, we wouldn't be in the situation that we're in right now when it comes to the climate. And because this stuff just works, and it's quick, and it's magic, and it's cool, and it helps me do my job easier, and blah, 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 that invisible cost that sits behind it is not something that people think about. And as I mentioned earlier, tiny, tiny behavioral changes at planetary scale can make a massive impact. And we're all in a position to do that in this room. We work in the digital industry. So, and the other thing to say is that the one power that we have as consumers is the ability to vote with our wallet or our feet. And what I mean by that is spend your money and spend your time on services that actually do seem like they give a shit about this stuff. And they are a little few and far between, but they do exist. So I'll give you an example, and this is not me trying to be like, yeah, I'm great, because I'm not. I flew here, I have a really polluting car, blah, 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 blah. But this isn't about changing your whole lifestyle and making life really inconvenient and shitty for everyone. This is about making little changes. So I haven't bought anything from Amazon for 6 months, and it's been really painful because you get in the habit of just, oh, I need some toilet roll, that'll be here tomorrow, or I need whatever. Minor inconveniences like that is because I don't agree with the way that they operate. And I think we can all make similar changes when it comes to this stuff. So things for you to investigate. Homework, if you like. The first one is model cards, and I really do need to hurry up, don't I? So model cards, I think in the EU, you folks have the energy efficiency labels on vacuum cleaners and stuff like that. We have them in the UK. Tells you it's like A to E or F or whatever. They exist for large language models. And they are supposed to be containing information like how many parameters it has, how it was trained, on what data, but also the carbon emissions of its training process and its inference, which is that using it bit. A lot of providers haven't bothered to use these because they're little shits. But what you should do is you should look around and find ones that have and use the right model for the task, as we talked about earlier. There's a thing called Sprout that you can investigate. There's a link there as well. Sprout is designed to adapt your prompts, so when you're talking to a large language model, based on how dirty the energy grid is at a given point in time. So if it's running on coal versus solar, for example, to give you a more efficient response. I always find it hard to pronounce that. Rukwav, I believe is how you say it, stands for something complicated that I'm not going into because we don't have time, but it's a slightly different way of building a large language model that can be between 10 and 100 times less intensive on computation. Not suitable for every use case, but it's something you should read about if you work in this space. And there's a great book that teaches you how to build your own large language model for those of you that are software engineering inclined. It won't be as good as the commercial offerings, but you'll learn a lot about the internals of these things and how complicated they are and what's going on, which I have found useful to educate myself on when it's appropriate to use this stuff. So that's good. Chin-strap penguin. Serious. I mean, look at its face. Not to be messed with. There's quite a few of those, 7.5 million breeding pairs, and it's 11. I don't like it as much as the emperor penguin. So, got about 15 minutes. So that was covered off the sustainability stuff. We'll come back to that in a second. The other thing I wanted to talk about is other considerations related to AI. First, what most teams are doing in the workplace when it comes to this technology, how they're using it. And what are they doing, most teams? Pretty much whatever they want is my observation. And it'd be interesting to see if this tallies up with what you folks have seen. But there's been a number of studies that have shown that since generative AI, large language models have come along, there's been a negative impact on people's critical thinking abilities. Now, that quote there on the left is written in magic science language, so I'll translate it into English. It's basically saying that the more stuff you blindly give to a machine to do, when you encounter a problem that requires a human, your ability to solve that problem will have been somewhat damaged. If you're not in the habit of actually having to use your brain and think critically, it can cause real issues. And I did a poll on LinkedIn a little while ago asking my connections if the companies they work for had given them guidance on appropriate AI tools, but also how to use them, because there's new stuff coming out all the time. And it was about a 50-50 split. So it might be that everyone in this room already knows the stuff I'm going to talk about. And if you do, I'm really sorry, but you can't leave because it'd be rude. But I do think we all have a bit of a responsibility to educate our colleagues on this stuff as well, including the sustainability bits and bobs. So what are the implications of this technology and the fact that people are sort of using it without necessarily engaging all of their brains? Have any of you used otter.ai? Thank you for putting your hand up. One solitary hand. So this was a thing that started appearing where I work and with some of our clients about 6 months ago. It's a service that you can invite to meetings, and it hangs out in your meeting. It will transcribe it for you and send you an email. And there were swarms of these things appearing in meetings, left, right, and center. Everyone was using it. It was the hot new thing. But no one had questioned, where's it hosted? What's it doing with the data? Is your data that you're feeding to this hungry otter, is it being used to train future versions of their products? Are they selling it to other people? Is it secure? All of the sort of due diligence things that you should be asking if you're going to adopt a new service went completely out of the window. So you've got that on one side, people adopting tools just because they are convenient and they make your job easier and they sound cool, but actually you should be thinking about this stuff, especially if you're working with certain types of clients. So that's on the one side. On the other side, Builder.ai, you might have heard of this recently, went bust because it turns out they didn't have an AI. They had 700 people in a warehouse. Do your due diligence. It's important to check this stuff. And then there's security concerns as well. So very recently there was an issue with the GitHub and MCP server, which is MCP is a hot new thing as well, which allows large language models to do stuff, which is brilliant and potentially terrifying. There was a vulnerability, actually not really to do with the MCP server, but due to the way things were configured. But this is another example of people just grabbing stuff and sort of sticking it together, and it'll be fine until it's not fine. And developers have been doing this for decades with the likes of Stack Overflow, but this stuff is significantly more powerful. There's also a lack of understanding of large language model output. So you'll find students using it to help write their essays, but it means they're not understanding what they're talking about. You'll find software developers using it to help them do their job, but not understanding what it's actually produced, and that can introduce serious security vulnerabilities. You've got prompt jailbreaks, and this is the most hilarious thing about large language models. So the people that make them, they control their behavior by giving them a prompt before the one that you give it that basically says, please be nice, don't say anything bad. And there's an over-reliance on non-deterministic systems. So the reason I spoke earlier about how this stuff works is that it's a prediction system, essentially. It's looking at statistical likelihood when it answers your questions. It's not out of the box reciting facts. And people treat it as if it is. And I've got some examples of that later. And I know, probably all of you know this already, but there's still some really silly things going on that means that I feel a responsibility to stand up here and talk about it. Oh, look, here we go. Here's some examples. So Air Canada were found liable for their chatbot's bad advice on plane tickets. And astonishingly, they tried to claim in court that the chatbot was responsible for its own actions, which is ridiculous. And just some tips, having built a bunch of chatbots in a previous life. If you're going to stick a large language model in front of the public to represent your business, you need to think about things like RAG. Some of you may have come across RAG, Retrieval Augmented Generation, which is a way of giving actual facts to a large language model rather than relying on it guessing what it thinks you want. You need safeguards beyond that. Please be nice, don't lie. Prompt at the start, and there's different ways of analyzing the inputs and the outputs. You need to test it, and you need, that says employees. That's meant to say employees. You need knowledgeable employees who understand how this technology works and won't go into court and try and claim that it's alive, because that's stupid. And then you've got a lawyer in the US using AI for their case research. So they used ChatGPT, and it made up a bunch of shit. And then they put it in front of a judge who found out. That's not only lazy, that's stupid. When you're using large language model output for anything, in my opinion, you should verify it's accurate. You should do that again, and then just maybe one last time, make sure that it's accurate. And if you don't know that, then go find someone who does. But I'm being a little bit harsh. We can't expect everyone to know how these tools work. I talked about this earlier. I think we have a responsibility to educate people on this stuff. Do you need to be using it? Is it the right tool? Are you using the right model? Making sure that people are verifying stuff. If you catch people introducing new tools that haven't been through some sort of due diligence, then talking to them about it. And then there's a rockhopper penguin. Don't look it directly in the eyes or your soul will disintegrate. There's only 1 million. Beautiful bird. Look at his hair. They're in serious decline, which is really sad. And I give that a 19 out of 10 because that is my favorite penguin. Absolutely delightful. So, some recommendations. I think I might come in on time. I'm so happy. Audit yourselves. So this is in the world of work. So what are your teams using, and what are they using it for? And you don't have to be in charge to do this kind of stuff, because the people in charge probably aren't thinking about it. This third one's really important for me. Do you have a culture of honesty without blame? If there are consequences for introducing a tool that maybe they haven't thought through properly, you get yelled at or you get disciplined, all that's going to happen is people won't stick their hands up and be honest about what they're doing. And you don't want that. That's not a healthy culture in the workplace. And they'll be doing all kinds of dodgy shit anyway, because people take the path of least resistance. I've done it. We've all done it. You just want to get your job done. You want to go home. You want to go to the pub with Nurhack. That's what you want to do. How are you keeping track of all this stuff? And I'll talk about how we do it at Air Studios, but like tracking which systems you're using and who's using them, and the privacy policies, and have you opted out of them selling your data to the highest bidder? And crucially, are you gaining client consent? Do your clients know you're using this technology? Because increasingly, they're waking up to the fact that people are potentially posting their intellectual property to online large language model services. So the BBC, one of our clients, is a great example. They're all over this. They want to know what we're using, what we're putting into it, what the safeguards are, all that stuff. Those of you that work with clients, they will be asking you these questions. I would get ready now. Give some guidance, but provide it in a range of formats. A 25-page policy document, no one's going to read it. They might use it as, actually, no, I won't say that. And make doing the right thing easy. Because otherwise people won't do it. And make doing the wrong thing an opportunity to educate your colleagues, because I think having a positive attitude to this stuff, despite the fact I've been ranting at all of you for the last 40 minutes, I think is really important. And understanding the tools that are out there and their implications. So this is some examples of some guidance that we've given internally about which things we think are safe and which things aren't. But we meet every week. We have an AI working group internally at AIR, and it's multidisciplinary. So we've got designers in there, project managers, useless people like me. We've got senior people in there to actually make things happen. So if we encounter a tool we want to adopt, we can just do it. And it's a great opportunity to learn from your colleagues. So I'm not a designer. I'm a horrible designer. But it's been really interesting for me sitting in that group to learn from my design colleagues about how AI is affecting their workflow and what they're doing with it and that kind of thing. And here's an example of our internal policy guidance where we've tried to educate people on the different applications of AI internally versus with clients, because they are different and you have to be careful. Now, super quick, because I've got 4 minutes. One thing we built with AI that I think is interesting and a good example of how you can use these tools in a responsible way is called C3PR. I didn't name that. It's a very nerdy name, but it's a really cool tool. And what it is a tool that helps us get through our pull requests. And for those of you that aren't technical or aren't developers, this is when a developer's been working on something for a bunch of time and wants to merge it in with everything else. This is to help us do that quicker. So it's made up of a GitHub action. So every time someone raises a pull request, GitHub, which is the tool where our code lives, takes that code, fires it off to a large language model, which we're hosting in AWS Bedrock. So we're not using ChatGPT. We're not using OpenAI. We're not using any other services. The reason why we're not is because some of our clients won't allow us to. So by using AWS Bedrock, we can make sure we have control over the region it's hosted in, we have control over the security and so on. We've got a custom prompt that essentially asks the large language model, which is a code-focused, fine-tuned model, to give us some feedback and an overall recommendation of whether we should merge it in or not. And then it makes a nice little poem at the end, which is nice. So I would love to actually put it up on the screen, but I fear, hang on, I'm really bad at this, as it turns out, and I didn't listen to you about looking at the bottom screen. So here's an example. So you can see here that a GitHub Action bot has posted this. I don't know if you can read it, but it's basically saying a summary. We should approve this particular pull request. It gives some scores on different aspects like security, performance, blah, 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 blah. And it has a little limerick that is specific to the pull request itself. Now, what we don't do is just take that for granted and go, cool, sounds great, we're going to merge it in. A human being still reviews it, but it helps them short-circuit that kind of process a little bit. And what that's led to, because we've had pipeline blockages regularly because PRs were taking a long time to get through. This was a really fun way of trying to improve that problem. It's good R&D for the team. It's a good learning opportunity. So we rolled it out for one of our major clients who were particularly annoyed with how long everything was taking. We onboarded them as a guinea pig, and what we've seen is about a 25% automatic intervention rate. In other words, 25% of the time it's gone, hey, maybe you should check that thing, which is useful because then we can get a human to check that thing. Okay, wow, 2 minutes, good. Summary. I think this might be the second last slide. You've done really well. Thanks very much. This stuff's really powerful. It's amazing technology. My take on it is I'm not going to stand here and tell everyone we shouldn't be using it because it's bad for the planet. It is a bit bad for the planet. But there are also lots of scenarios where it makes sense to use it because it can free up humans to do other things and so on. The security and environmental concerns of this stuff are real. There's no doubt about that, particularly security. And I think everyone who is interested in this has a duty, a responsibility to educate the people they work with, but also people at home on, there is a hidden cost to this stuff. Just because a big siren doesn't fire off every time you generate an image to tell you that it's using loads of carbon doesn't mean there's no cost there. You have to be really proactive with stuff. It's moving so quickly. I've never seen anything like it. There's lots of interesting people you can follow who are doing really innovative work in this space that you can find on Blue Sky or X. I'm talking like I use these things. I don't, but I'm sure they're on there. And the main thing, if you take one thing apart from the fact that rockhopper penguins are really beautiful, the one thing I'd like everyone to take from this talk is to just think before you use this stuff. And it sounds like I'm being patronizing and horrible, but there's plenty of evidence that shows that people are just jumping on board with these things before they've had a chance to actually examine them and do the usual levels of due diligence that you should be doing as professionals working in this industry. And that's it. Thank you very much.